we are joined by two young entrepreneurs who are doing true pioneering work with their family-run company. They are developing bio-based and biodegradable polymers, materials that are not only high-performing but also sustainable. Eduard Putsch is the head of the production and works closely with his father on research and development, and his brother Max is in charge of sales and makes sure that the innovative materials reach out to the market. Together, they represent a new generation of business on that combines responsibility with innovation. Please give them warm hands here and welcome them on stage for their lecture of the feasible future of plastics from vision to concrete applications. Stage is yours.
Yeah, thank you very much, ladies and gentlemen. Nice to be here, and yeah, we hope to give you some other informations or new informations about PBS. In the last presentation, we heard a lot about PBS already. So, yeah, we do this in a combined mode. I talk about the sales, and my brother takes the technical stuff. In this case, Eduard, please go ahead.
Thank you very much. A little bit lower. So, yeah, so when somebody talks about biopolymers, is often interesting what is the definition for them, or what does the bio and biopolymer stands for them. So for us, there are three major points. The first one is that it must be bio-based. So that the monomers which you use to produce the biopolymer are from renewable resources like waste or biomass. The other one is that it's important that it's biodegradable. So when it sometimes goes on in the nature, after some time it's completely gone. And the third one, which is also a very big point, is that it has similar characterization like polyester, like PET or PBT or PP and PE, because we think about that when we develop new products. This is a nice thing, but when the customers who make the application can fit with the change, it doesn't help. So our thought was to develop a compound where the customer can only add it up in his injection molding machine and doesn't have to change anything. He doesn't have to buy a dryer or change the mold. So this was the main target for us, that we have these 3 points. And so we started with other institutes or companies to apply for projects. One of them was a national big project called Rubium. And the task was there to build the whole chain, from the fermentation to the polymerization, then through the compounding part, which is our part, and then in the end to produce the applications. And our part was to find the right polymer. And I remember the story where my father bought some bags of biopolymers and started in the evening to test it on the injection molding machine. And yeah, it doesn't. The trial was not so good, and he was really frustrated in the end. But I think many of you knows already my father. He is not a guy who gives up. So in the end, there was a bag left, and he thought, okay, it's the last trial for the day, and he put it in the injection molding machine, and suddenly it works. So automatically the parts came out. And this was the start of our biopolymer, of the journey with PBS. Wait a moment. Yeah. Polybutylene succinate. I think many of you heard now everything about this material. I will give you a short introduction about it from our side. So, like Dr. Hess mentioned already, it can be the 2 monomers can be both bio-based and both biodegradable. And when we receive the material, we make our compounds. And after that, it goes to the customers, and he makes his application. And then you can see this possibility that we have here, that the PBS is also recyclable. So when it's damaged, the application, or it's not useful anymore, there is this part. And there is a part missing, but I will add it up for you. It's the biotechnology cycle. And later on a later layout, I have then also a video to share with you how you can cut the polymer chains of the PBS compound, and in the end you have the pure monomers left, and with this monomers you can then produce again the PBS, and after that the compounds which we use to make the application. And the last one is the biodegradable part. So as everybody know already, we produce the compounds for the plant pots, and when you put it in the ground after a few months, it's completely gone. And this is the advantage point for PBS, because the two first cycle, that it's a long life article, or the recycle part, it's for many conventional materials already available. But the two other points with the biotechnology cycle and the biodegradable, it's a unique point that PBS has. And I think the next one is, yeah, exactly. So we started Rubio, and it was very successfully. And after that, we thought, okay, what is the following up project? And we had a new vision. This is the compact production system that we want to start in the middle of Germany. And we created a vision for all of you. And here you can see, this is the plan that we want to have it in a few years also in the middle east of Germany, because we have all the things here. So we have Ude Inventor Fischer, who can build this product line, but we have also the raw material, like the biomass. After that, it goes in the fermentation, which we have also here. After that, it goes to the cleaning. You have to clean the monomer, and after that, it comes the hydrogenation. And the next part will be the polymerization, where you combine the two monomers, butanediol and succinic acid. The next is also a big important part. It's our part, the compounding part, where we develop the compounds. And we have also in all this Middle East area the customers who can produce this application. So this is our target for the next few years, because one of the things is we have many additives already here in Germany or in Europe, but as also Mr. Pawlikowski already mentioned, the buildings where the PBS are produced are mostly in Asia. And so we have the transport costs, which are really high, and our plan is for the future to have this PBS also here in Europe in a perfect way in Germany. So, and I think now will be my brother. Continue.
Yeah, I will tell you something about our family. Who are we? We are more than 100 years on the market, in the 4th generation of plastics. Also, we do a lot of R&D stuff, as my brother already mentioned. So, our part is to generate new compounds for different applications. Also some R&D projects to generate the new compounds. We are open for it. Dr. Hess told a bit of our next slide. We have heat resistance, as we already heard, about 150 degrees. This is pretty good for nearly most of the applications. If you see the cups at our booth or something like this, you can put it in the dishwasher and everything is good. Also, we can produce 100% bio-based and biodegradable compounds already. Colors is no problems for us. We use also natural colors, or if it goes in other applications, we can use normal master batches as well. Okay, we are 100% recyclable, and this is pretty good, but if the application or the part goes in the environment, it will be gone after a few years. We say per millimeter wall thickness, it takes around about 1 year, and then the material is gone. Yeah, here is a short product line overview what we did the last years. The main topic was to set a melt flow rate. So that means we have a melt flow rate 1 to nearly up to 100 for different applications. Yeah, if we go for the lower melt flow indexes, we can use it for extrusion grades or something, extrusion applications. And yeah, if we go for the standard, it's the 120 or 140. This is our main products for injection molding parts. The parts you can see also at our booth in the foyer later on. Yeah, what we did already. Our materials are commercialized already. So we heard about the flower pots. We saw them already. We have the cups. We have some foil. We can do bottles out of the material, and yeah, this is just a short overview what we can do with the material. This is our newest grade. We work for around about 40 years for the automotive interior part, and yeah, then it's pretty close that we try to get the PBS also in the car. Yeah, my father and my brother, they are working hard on it, that the material fits for the automotive standards. And I think we are on a pretty good way. Yeah, for some OEMs and tier ones, we will do in the next month some parts from our material, and then we can test it and see how it works.
So one point about this automotive compound is that this came out also of a founding project together with the Fraunhofer IMVS and the PSM Polymer Service in Merseburg, where our plan was to develop or to increase the impact resistance of the PBS. So we started with latex, with rubber, to add it in our PBS, and now you can see the different, or when you compare it with a classic PPT15, which is in the car, most of it inside, that we are in many areas quite there. So, and this was the vision and the target of this one project. And another thing of PBS is a PBS matrix, so it's really flexible, and this is a SME from the Fraunhofer IMVS, where you can see now that the latex particle, it fits really good in this PBS material, and this was the case why the impact resistance was then in the end so good. This is one point when you say, okay, you have maybe a good compound for the automotive industry, but another, then you have to see, okay, if you find other big important points. And another point, yeah, it's now the energy consumption. So during our Rubio project, we had also an LCA a task where somebody was at the factories and installed his machine and checked out, okay, what is the energy when you produce a PP compounds and PPS compounds. And yeah, we found out that we have less energy when we produce our compounds with PBS to compare it with PP, and therefore I have also a short, nice story, because last week we had a trial in another country to produce some application, and I sent him the parameter to produce the material, and he called me back and he said to me, there's something wrong about it, it cannot be right. And I was a little bit confused, and I asked him what is the problem. He said, okay, there's something wrong with the temperature, it's too less. And he thought, you cannot produce between 130 and 190 degrees this application. And I said, yes, it's possible. And the thing was, he was also so confused, was he only worked with PP, and with PP you have to work with 22 to 40 degrees to produce the material. And after the trial, he called me back and he said he was really surprised about the production line, because we can produce with less temperature. And this is also a big advantage that we have also for the automotive industry, that we have bio-based and biodegradable parts, and you use less energy for them. And I think now the next slide will be a video where we show you how the biotechnology cycle will be shown. There will be a pod together with the University of Leipzig. We wanted to show how is the degradation well of the flower pot. And now you will see it. Here you can see our flower pot at the University of Leipzig, and this was the biotechnology part where they cutted the polymer chain, and it was the perfect way, to be honest. So it's not in the realistic way that you have your flower pot, and then after 29 hours, it's completely gone. But we wanted to show that it's possible, and it's transparent. But here you see separates the monomers, and down is the filament, it's the filler, and yeah, this can be done with our flower pot. So in the end, when you have the flower pot, please put it in the ground, and after some time, it will be also completely done. And I think, yeah, I can do it also by myself. Thank you very much for the attention, and that we could stay here to present our company. And Max, do you have some other words?
One
yeah.
last
Okay.
on my side. Yeah, if you have any questions, maybe not now or later, we are out in the foyer. You can talk with us at any time. And if you need some biopolymers for your projects or trials or something like this, you can talk with us at any time, not only the compounds. Thank you very much, ladies and gentlemen.
Thank you so much, guys. It's a pleasure having you here, explaining about your offering. Also very interesting findings. Are there any questions from the auditorium for them?
Thank you for a brilliant presentation. I have 3 quick questions. The first one, if you measure this shrinkage in a mold, the first question. The second one, if you test it in autoclave sterilization. And the third one, how long does the process in mold last finally? Is there any difference with the PP? Thank you.
We have a shrinking, but we are planning to stabilize this part. But to be fair about the shrinking problem, I have then to contact you to the man at the exhibit who can, or maybe do you have something to say about that?
You know, in the end, it's if you ask me, it's a molding thing or not. I mean, wait, we give it to the technical guy.
Okay, the shrinkage is about 1 to 1.3%, to be precise.
And the second question is related to autoclave sterilization. There is something like a 130 degrees and with a bit higher pressure. Obviously, I mentioned the medical sector.
No, sorry. We didn't get into this kind of application so far. What I can tell you is that at 100 degrees is the maximum temperature for usage. Maybe for sterilization, 105 degrees, something like that, but not very much more.
We may try, okay. Let's discuss later on.
Exactly.
And the third quick question, if there's any differences in mold cooling, the time?
Not really, no. It is easy to mold it. For our products, you don't even need a dryer. You just put it in the machine, and the normal conditions, like, for instance, for the flower pot, you need some warmer mold, but you also need that for polypropylene. That's the same, and there is no different to existing plastics.
Thank you very much.
Thank you. Yeah. Sometimes the father has to come.
Thank you.
Yeah, is there another question? I mean, good questions. Yeah, maybe from the back, another one?
So I'm not a plastic guy, I'm a mechanical engineer, but yesterday I talked to you and I learned that the pots, they biodegrade quite fast, and maybe we can, you're working on how you can extend this time. And I just a stupid question. I heard about BioCoal, a company who integrates coal into polymers, and as coal is also biodegradable, but it has a super long range to biodegrade. May it be attempt to integrate coal to prolong the biodegradability of your PBS?
So first, thank you for the information and for the tip. Yeah, we already started with this part because some customers said already, yeah, okay, we have the flower pot and it's too short because the polymer change is really short with the melt flow. It's so high. So we are already planning or developing some trials where we are testing how long it can be, but this is a little bit secret which kind of additives we use right now, but it's a nice tip. Thank you for that, and maybe we can test it, but yeah, this is a thing which we already have in our mind and have to develop it. Thank you.
Hello, Czulak from the Polish cluster of the composite technology. My question is, how looks like with the flammability of the material? Because I see some potential for the application of this material, but the question is how it look like with the flammability.
So there was already in a layout, but it was only too short. We have already developed a flame-resistant material. So this is already available, and we made also some tests. About the test, I think it was V2. In this case, it goes to V0. So we successfully had this test, and so yeah, this is possible. So with PBS, we found out it's really flexible. You can use it for any kind of application, from the blow molding, blocks and extrusion to injection and to fin injection, and also flame resistant. So yeah, we found out it's a very good PBS biopolymer and already available for flame resistant.
Thank you very much, Eduard Putsch, Max Putsch. Thank you for the exciting lecture.